Hi guys. So today we're going to look at how to graph probably the most difficult graphs we'll do all year. Also the most difficult graphs that you did in Algebra 2, and those are rational functions. Now what we're going to do is we're going to find all the pieces of a rational function first before we actually draw the graph. So today there's actually not going to be any drawing of the graphs. We're just going to find all of the components, and there are a lot. Now the good thing I'll tell you though is that it's actually not difficult algebra to do each of these. As long as you can factor, it'll be very easy for you to find each of those things. What's difficult is just how many steps that there are. There's just kind of a lot to do. So the most important thing you need to know about rational functions, the first thing that you have to do is factor the top and the bottom. Okay, we always have to factor the top and the bottom first. After we do that, the first thing we look for is a whole. So if you remember from Algebra 2, a whole is what's going to happen when you have a factor that cancels out. So if a factor cancels out, that is going to leave a hole in your graph. The hole is going to have an x-coordinate and a y-coordinate. To get the x-coordinate, you set the canceled factors equal to 0 and solve. So basically you're finding the zeros of that factor that you canceled out. To get the y-coordinate of the hole, you take the x that you just got and you plug it into the remaining function. So after it's canceled, you look at what's left. So let's look at an example here. I'm going to factor the top and the bottom. Now the top does factor. It has a GCF. 3 can come out. The bottom, looking for what multiplies to -6 and adds to 1. That's going to be -3 and +2. So you'll notice there's the same factor top and bottom. That factor is going to cancel out. So since that factor cancels out, to find the whole, the x-coordinate is going to be the 0 of that factor. Okay, if I took it and set it equal to 0 and solved, I would get 3. Well, now after it's canceled, let's look and see what we have left. There's a 3 at top and an x plus 2 on the bottom. To find the y-coordinate, I'm going to plug in 3 for x into anywhere there's an x in the remaining function. So if I replace that x with the 3, then I would get 3 divided by 5, and that's my y-coordinate. All right, so factor and cancel first. If a factor cancels out, you're going to use whatever's left over. So you're going to use the remaining function for everything else that we find on this graph. Okay, so once it's canceled, it's canceled. Okay, we're going to use that function for everything else. All right, the next most important piece is what is the vertical asymptote. So the vertical asymptote, if you remember, that's the line that you cannot cross. All right, the vertical asymptote happens when you set the factors of the bottom of the denominator equal to 0. And the reason this happens is because you can't divide by 0. That's why we get a vertical asymptote. Okay, you cannot divide by 0. So let's look at that same example we just had. Okay, well that's 3, x minus 3, x minus 3x plus 2. The x minus 3 is canceled out. So again, we're using the remaining function. What's at the bottom is x plus 2. If I set that equal to 0, I would get x equals -2. That's my vertical asymptote. All right, horizontal asymptotes. The math behind these is actually really easy, but this one has the most rules to remember. So what we do to find a horizontal asymptote is we look at the degree of the top of the function and the degree of the bottom of the function. All right, so remember the degree is the biggest exponent when it's in standard form, or we add up all the multiplicities if it's in factored form. If our graph is what we call bottom heavy, so the degree on the bottom is bigger, our horizontal asymptote is y equals 0. We don't have to do any work, it's just y equals 0. If our graph is top heavy, it's a higher degree on the top, there is no horizontal asymptote, but there could be a slant asymptote, and that's what we'll find next. Now, if you have the same degree top and bottom, then you divide the leading coefficients. So the number is out in front. So again, looking at our previous, I'll go ahead and use the canceled one. If we look at the degree of the top, there are no x's, so that's a degree 0. If you look at the bottom, it's x to the first. So this is a higher degree on the bottom, so our horizontal asymptote is y equals 0. All right, a slant asymptote, it will happen instead of a horizontal. You cannot have both horizontal and slant. It's going to be one or the other. All right, slant asymptotes occur when the degree of the top is bigger than the bottom and exactly by 1. So if it's 1 degree higher on top, you're going to have a slant asymptote. So the way you find a slant asymptote is you divide, but you can ignore the remainder. So let's look at this example over here. I'm going to factor the top, so x minus 6 and x plus 1. And I always factor top and bottom first because I want to make sure nothing cancels. Okay, so nothing canceled here. Well, now, again, it's a bigger degree on the top. There is no horizontal asymptote. But because it's 1 degree higher, there's going to be a slant asymptote. So the way we find this is we use division. So I'll do synthetic division because it's a little bit easier. I'll bring down my first, multiply and add, and I can ignore the remainder. So my slant asymptote is x minus 7. All right, so those are asymptotes. Those are probably the most important pieces. The other things we're going to look at are the same thing we found in many of our other things this year. X-intercepts, Y-intercepts, domain, and end behavior. So X-intercepts, remember, those are coordinates. It's going to be some number, comma, 0. The way we find an X-intercept is we set the factors of the top equal to 0. And the reason is because if you have a 0 at the top of the fraction, it doesn't matter what's on bottom, you get 0. And that's what X-intercepts are. They're zeros. Okay, so remember, another word for that is zeros. So let's check this one, okay? Well, again, let's write the factored form. This is the one we just did. And I realize now that I factored it wrong. This is x minus 3 and x minus 2. Sorry, guys. It's okay, though, because nothing cancels out still. So that part's good. All right, so from here, we're going to find the x-intercepts. So the x-intercept is when the top equals 0. So one of them is 3. And the other is 2. All right, y-intercepts, we find this the same way we always find a y-intercept. What we do is we plug in 0 for every x. So this will be really easy because if I plug in those zeros, all that's left is 6 over 2. So my y-intercept is 0, 3. All right, domain. We actually did this at the very beginning of the year. So domain for these, we do not include vertical asymptotes or the x-coordinate. So the x-coordinate of the whole. All right, so let's look at that same example we had at the beginning. So that same one from the beginning. There was a whole when x equaled 3, and there was a vertical asymptote when x equaled negative 2. So my domain is going to skip those two values. So the way we would write that is we start at negative infinity. Then we keep going until whichever of those two numbers is smaller. So negative 2. We put a parenthesis because we don't touch it. Then our graph picks right back up at that same place, but we don't actually touch it, so it's still a parenthesis. Then it keeps going till 3. Doesn't actually touch 3, so we use a parenthesis. And then again, it picks back up, and it keeps going to infinity. So that's how we write our domain. All right, and then the last feature is end behavior. So for end behavior, we look at the horizontal or slant asymptote. So on this one, our horizontal asymptote was y equals 0. Well, if the horizontal asymptote is 0, our graph is going to approach 0 on the ends. So both negative infinity and positive infinity will approach 0. All right, so to do some examples, we're just going to fill in basically that same chart. All right, so the first thing we always do is factor. Now this one here, already factored. Don't need to change anything. Nothing canceled out, so there are no holes. Vertical asymptote, we set the bottom equal to 0. Horizontal asymptote, these are the same degree. So we're going to divide the leading coefficients. X-intercept, set the top equal to 0. So I get 3 over 2. Y-intercept, you plug in 0 for all your x's. So I get negative 3 divided by negative 1. Domain, it will not include 1. So I'll start at negative infinity, go to 1. Pick back up, go from 1 to infinity. End behavior, we approach the horizontal asymptote, which is 2. All right, let's try another one. All right, let's factor first. That's a difference of squares. Factors into x plus 3, x minus 3. So holes, there are none. Vertical asymptote, this time there's 2 because there are 2 factors that I can set equal to 0. So -3 and 3. Horizontal asymptote, this one's bigger on bottom. Okay, it's a degree 1 at the top, degree 2 at the bottom. So bigger degree on the bottom, it's y equals 0. X-intercept, we set the top equal to 0. Okay, so if I do x minus 1 equals 0, I get x equals 1. So 1 comma 0. Y-intercept, I plug in 0 for all my x's. So I would get -1 over -9. And then domain, we're going to skip the vertical asymptotes and holes. There are no holes, but there are 2 vertical asymptotes. So I start with the negative infinity, I go to the smaller number. And I'm going to run out of space, so sorry about that. Then parenthesis, union, parenthesis, pick back up at the same number, go to the next number. Parenthesis, union, parenthesis, same number, keep going until infinity. All right, and then end behavior, as x approaches negative infinity and positive infinity, we are approaching the horizontal asymptote, which is 0. All right, let's go ahead and factor the next one. Now on the top, to make that a little bit easier, hopefully you notice there is a GCF. So I'm going to take out that GCF first. And I can factor the bottom. That's going to be -4 and +2. So then the top, after I take that GCF, I can factor what's left. Multiplies to 1 and adds to -2, x minus 1, and x minus 1. So again, there's still no holes, okay? Nothing canceled out. Vertical asymptote, set the bottom equal to 0. Horizontal, so I'm going to divide the leading coefficients. So that's 2 over 1. X-intercept, set the top equal to 0. The 2 does not have any x's, so that does not change my y or x-intercept. My only x-intercept would be 1, 0. Y-intercept, plug in 0 for all your x's. So that's going to be 2 over -8. So that is -1 over 4. And then domain, I'll write it over here so I have space. So you start at negative infinity. You keep going until the smaller of the 2 values. Then union, parenthesis, pick it back up. Go to the next value. Parenthesis, union, parenthesis, pick back up at the same number. Keep going to infinity. All right, then the last one on there. Again, our ends are going to approach the horizontal asymptote, which on this example was 2. All right, so let's look at a few examples of what we just did on that chart. So we're going to do the exact same thing. We're just going to fill in each of those components for this function. So the first thing that we're going to do is we're going to factor it. Well, in this case, this first one's already factored, so I don't need to worry about that. So that's going to look the same. And I apologize if you hear my cat in the background. So in this case, nothing canceled out. There were no holes, so there's nothing here we need to worry about. And then to find our vertical asymptote, we're going to set the bottom equal to 0. So if I did x minus 1 equals 0, then I would get that x equals 1. For the horizontal asymptote, I look at those rules. We see if it's top heavy, bottom heavy, or the same degree. Well, if you look at the top, the degree is 1 because it's 2x. The bottom is just an x, so those are the same degree. So what we would do is we would divide those leading coefficients. So 2 over 2, or 2 over 1, I get y equals 2. X-intercept, we set the top equal to 0, and I solve. So I get x equals 3 over 2. Now remember, your x-intercept is a coordinate, so I'm going to write it as 3 over 2 comma 0. To get the y-intercept, I would plug in 0 for all of my x's. So I would get -3 divided by -1, which would just be 3. Domain, we exclude the vertical asymptote and the hole, so I'm not going to touch 1. So I would start at negative infinity, and then I would go all the way until 1. It doesn't touch 1, so I'll use a parenthesis. Then it picks back up, so I'll do a union, a parenthesis, and a 1 again, and then it keeps going until infinity. And then end behavior, my ends will approach the horizontal asymptote, which is 2. So both ends will approach that horizontal asymptote. All right, let's try another. So this one is actually going to require us to factor. So factor the top and factor the bottom. So the top is going to factor into x minus 3, x plus 2. The bottom is a difference of squares, so it's x minus 3, x plus 3. So we can see that we're going to have a factor here that cancels out. That means we're going to have a whole. Because I canceled out x minus 3, the x-coordinate of the whole is 3. Then I would plug 3 in to get the y-coordinate. So everywhere there's an x in the remaining function. So my whole is at 3, 5 over 6. Vertical asymptote, again, at this point, we're just looking at the remaining function from this point going forward. Vertical asymptote, I set the bottom equal to 0. Horizontal asymptote, in the remaining function, it's the same degree. I have 1x on top and 1x on bottom. I divide those leading coefficients, which are 1 and 1. So 1 over 1 is 1. X-intercept, we set the top equal to 0. And I'm just going to write it as an ordered pair. Y-intercept, we plug in 0 for x. So I end up with 2 over 3. Domain, we're going to exclude the vertical asymptote and the whole. So the two values I cannot have at the bottom are negative 3 and 3. So I'm going to start at negative infinity and then go to the smaller one, which is negative 3. Parenthesis, union, parenthesis, pick back up at the same number. Then I go to the next number, which was 3. Parenthesis, union, parenthesis, pick back up at the same number, and it keeps going until infinity. And then in behavior, we're going to approach the horizontal asymptote on both sides. All right, if you feel comfortable, pause the video, try this one on your own. All right, so to factor the top, I'm actually going to start by taking out my GCF. That's going to make this a little bit easier. So if I take out that 2, then the bottom is going to factor into x minus 4 and x plus 2. All right, so then I can factor the top a little bit easier because now to factor that inside trinomial, it's just the numbers that multiply to 1 and add to negative 2. So that's going to be x minus 1 and x minus 1. All right, so now it's factored. So now nothing canceled out, so there are no holes. Vertical asymptote, we set the bottom equal to 0. So there's going to be 2 vertical asymptotes here. X equals 4 and x equals negative 2. Horizontal asymptote, these are the same degree. So I'm going to divide the leading coefficients, which is 2 over 1. X-intercept, I set the top equal to 0. Well, that's the same factor, so it's just x equals 1. So 1 comma 0. Y-intercept, I'm going to plug in 0 for all of my x's. So it's going to be 2 over negative 8, which is a negative 1/4. Domain, we're going to skip both vertical asymptotes. So start at negative infinity. I'm going to go to the smaller number first. So negative 2. Pick back up. Go to the next number. And pick back up and keep going. And then in behavior, we're going to approach the horizontal asymptote at 2. All right, so let's do another. Again, we're going to factor first. So top multiplies to negative 20 and adds to negative 1, negative 5 and 4. Nothing cancels out, so there are no holes. Vertical asymptotes at the bottom equal to 0. Horizontal asymptote, this time there's none, but we're going to have a slant asymptote on this one because the degree on the top is higher than the degree on the bottom, and it's higher by 1 too. So we're going to have a slant asymptote. So the way we find a slant asymptote is we just divide and we ignore the remainder. So I'm going to use synthetic division. So I'm dividing by x minus 1. So positive 1 goes in the box. I'll write my coefficients. I'll bring down the first. I can ignore the remainder. So my slant asymptote is y equals x. All right, x-intercept. There's going to be 2 of them because there are 2 factors on the top. Set the top one equal to 0 and I get 5.
Set the other one equal to 0, and I get -4. Y-intercept, plug in 0 for all your x's. So I get -20 over -1, which is just 20. And then domain, I start at -infinity. I cannot touch holes or vertical asymptotes. There are no holes. There's only one vertical asymptote. End behavior here, it's going to approach the slant asymptote. So think about what the slant asymptote's doing. The line y equals x looks like this. So as x approaches -infinity, f of x approaches -infinity. And as x approaches positive infinity, f of x approaches positive infinity. All right, we got one more here. So again, let's make sure we factor now. This is probably one of the most missed ones because people, when they factor, forget to take out the GCF. So on the top, there's a GCF of 2. On the bottom, multiplies to -10, adds to -3, is -5 plus 2. So we can see that the x minus 5 factor is going to cancel out, which means we're going to have a hole when x equals 5. I'm going to write my remaining function over here. All right, so to get the y coordinate, I'm going to plug 5 in. And I get 2 over 7. Vertical asymptotes at the bottom equal to 0 in the remaining function. Horizontal asymptote, this is going to be bottom heavy. There's no x's on top, there's an x on the bottom. So y equals 0. X-intercept, there are no more x's in the top. So I can't actually set that equal to 0. 2 doesn't equal 0. So since there's no x's in the top, there is no x-intercept. To get the y-intercept, plug in 0 for my x's. So that's 2 over 2, which is 1. Domain, again, we don't touch the hole. We don't touch the vertical asymptote. Start at -infinity. The smaller value is -2. The next value is 5. And then it keeps going to infinity. And then end behavior approaches the horizontal asymptote, which is 0. So again, a lot of information on these, a lot of things to find, but each step is not that bad as long as you remember how to do it and as long as you can factor to begin with. So the last thing we're doing is we're just going to work backwards. So we're going to write this based off the features. So this first one tells me I have a hole when x equals -7. So if there's a hole, a factor is going to cancel. If it happens when x equals -7, the factor that's going to cancel is x plus 7. So that means I need x plus 7 on the top and bottom. Asymptote of y equals 0. That's a horizontal asymptote. That means the bottom degree is higher. And then if I have an asymptote of x equals 5, then x minus 5 is going to be on the bottom. So the way I would write this is x plus 7 at the top, x plus 7 on the bottom, and x minus 5 on the bottom. All right, let's do another one. There's a hole when x equals 3. So x minus 3 is the factor, top and bottom. X-intercept at 5, 0. So x minus 5 is the factor, x-intercept, that's on the top. Asymptotes of y equals 3. That means we're going to be same degree and a coefficient of 3. And then x equals 0, the factor is just x, and that's going to be on the bottom. So what this would look like, I'd have x minus 3 top and bottom. Oops, I lost my x. I'm going to have x minus 5 at the top. I'm going to have x at the bottom. So these are currently the same degree. Okay, I've got a degree of 2 at the top, and I've got a degree of 2 at the bottom. So in order to make the horizontal asymptote y equals 3, I just need that coefficient of 3 out in the very front. And I'm done. All right, so like I said, a lot of information today, but we are going to practice this and work on it some more next class as well.